Now, Newton's second law. So if a net force acts on an object, the object will accelerate in the direction of the net force. This acceleration is going to be directly proportional to the net force and inversely proportional to the mass of the object, right? So what does that mean? If you push harder, it's going to accelerate more. If the object is heavier, it's going to accelerate less for the same push. Okay, so in simple terms, when you push something, it speeds up or slows down in the direction that you're pushing it. And then in mathematical terms, we're going to have Fnet equals ma. So for the first law, we had Fnet equals 0. Now we've got Fnet equals ma, right? And to put it on a graph, you have direct proportion between Fnet and a, and inverse proportion between the acceleration and the mass for a constant Fnet. Right, so for Newton's second law, what's very important is that the forces and the components of forces in the line of action of the acceleration represent Fnet, right? So if something is accelerating rightwards along a surface, all the forces that are horizontal or have components that are horizontal, that's what we've got to include in Fnet, right? And also important then is that the forces and components of forces that are perpendicular to the Fnet, so usually perpendicular to the surface, has to be balanced. And when do we use this? We use it when the object is slowing up. Wow, I'm inventing fantastic English here. Object is speeding up or it is going to be slowing down, right? So now we're going to do this example here. So we've got this outrageously colorful horse, and that colorful horse is dragging a 10 kilogram crate with an applied force of 200 newtons. Now the rope forms a 15-degree angle to the horizontal and the coefficient of kinetic friction is 0.1. We have to find the acceleration of the crate. Okay, so we want to represent this situation in a free body diagram. So we've got the 200 newtons that is going up in that direction. We know it's a 15-degree angle. We know there's a normal going up. We know that we've got friction, and we know that we're going to have an Fg. Okay, so now if we have a force that's not in the direction of the acceleration or that's not perpendicular to the acceleration, we want to find its components that are in the direction or perpendicular to the acceleration. So this 200, we've got to go break into an Fx, right? And then an Fy going up, okay? Which I'll, for the sake of the force triangle, write it there with that there. Okay, so what do we know? We know that there's horizontal acceleration. So in the horizontal line of action, we've got Fnet equals ma. And we know that if it's accelerating in the horizontal line of action, then perpendicular to that, the forces have to be balanced. So in this up-down line of action, the vertical, we've got to have that our Fnet is 0. So in other words, the normal going up plus the y component going up has to be equal to Fg going down, right? And then for this Fnet equals ma, if I take rightwards as being positive and leftwards as being negative, then this Fnet is going to have the Fx that is going to the right in the positive direction minus the friction, which is going to be equal to this ma. Okay, cool. So now we've got equations. Now we just need to do the math. Okay, so we know that the friction is actually going to depend on the normal, because the force of kinetic friction is equal to the coefficient of kinetic friction multiplied by the normal force. So we've got to go find the magnitude of this normal force before we can actually go and find this acceleration, right? So here the normal is going to be equal to Fg minus Fy. I'm just taking Fy to the other side. And then the Fg here is going to be the mass of the crate, which we said is 10 times 9.8. So 10 times 9.8 minus the Fy. Now here the Fy is going to be, let's see, opposite the 15-degree angle. So I'm just going to go and straight up substitute it in there. So it's opposite the 15-degree angle, so it's going to be the 200 times sine 15, because we know we use sine if it's opposite, right? So then 10 times 9.8 minus 200 times sine 15 gives us a normal force of 46.24 newtons. Okay. 46.24 newtons, right? And that means we can actually go find friction. So friction is going to be this 0.1 times the normal, which is the 46.24, right? So that times 0.1 is then going to be 4.62. Okay, so that's 4.62 newtons. Okay, right, let me just separate this nicely. Okay, and then Fx is now the force that is adjacent to the angle. So Fx is going to be the hypotenuse, the 200 times the cos of 15, because it's adjacent, minus this 4.62, and that's going to be equal to ma. We know the mass is 10, so that's going to be 10a. How wonderful! We've now only got a left, and that is the object of our desires, what we are trying to find. So 200 times cos 15 minus 4.62 gives us something that we divide by 10, and that gives us 18.86. So the acceleration is going to be 18.86, and then we just need our unit. And the unit is meters per squared second, and that's going to be off to the right. Fantastic. Let's do the next example. So for the next example here, we've got an outrageously blue man, and he's pushing a crate up a 25-degree incline. The mass of the crate is 5 kilogram, and the coefficient of kinetic friction is 0.2. Find the force with which the man is pushing if the crate accelerates at 0.5 meters per square second up the slope. Okay, so what we've got to do here again is understand the free body diagram. So we've got this Fg going down, right? We'll have friction coming this way, we'll have the applied force going that way, and then there's going to be a normal force going up. Now, once we take that Fg and we turn it into an Fg perpendicular and an Fg parallel, right? We'll see that the Fg perpendicular has to be equal to the normal, right? Because that's perpendicular to the acceleration, and that this here, the things that are parallel to the surface, that's got to represent the Fnet, right? So we're going to have these equations, right, where we know that the normal is equal to Fg perpendicular in that perpendicular line of action, right? And we know for our Fnet equals ma, if we take up the slope as the positive direction and down the slope as negative, then this is going to be the applied force minus the frictional force minus Fg parallel, and that's going to be equal to ma. Now, to find Fg perpendicular, right, let me just draw this nicely. We know that the crate is 5 kilograms, right? So 5 times 9.8 gives us a weight of 49. Okay, so we know Fg is 49 going down, and then I'm just going to draw this here nicely because I see I've made a mess. So there's Fg perpendicular, here's Fg parallel, here's our 90-degree angle, and then this here, the angle between Fg perpendicular and Fg is going to be the angle of the incline, the 25 degrees. Okay, right, so to find Fg perpendicular, because it's next to that angle, we're going to use cos. So 49 times cos 25 is going to give us Fg perpendicular, which is equal to the normal in this case. So 49 times cos 25 is going to be equal to 44.41 newtons. Fantastic. And now we've got normal, and again we're in this situation where we're actually trying to go and find friction, and friction depends on the normal because they gave us mu k. Right, so the force of friction is going to be equal to mu k times the normal is equal to 0.2 times the normal force, which we just found. Aren't we good? So that times 0.2 is going to give us 8.88 newtons. Fantastic. So we've got the 8.88 newtons there, and now we should be pretty close to being able to sub in here, right? So the applied force is what we're trying to find, so I'm just going to leave that. Minus friction that we've got Okay, FG parallel we haven't calculated, but we know what it's going to be because it's opposite that 25-degree angle. So it's going to be 49 times sine 25, right? And that's got to be equal to MA, which we know the crate has a mass of 5. And we know that in the positive direction up the slope, we're accelerating at 0.5 meters per squared second. So I'm going to put that there. Okay, so now we are in luck, because now I can say FA equals, and I'm going to take the 5 times 0.5, I'm going to add to it the 49 times the sine 25, and I'm going to add to it the 8,88. And when I do that, I get here that the FA is 32,09 newtons, and that's going to be up the slope. Wunderbar. Okay, so now it is once again your turn to give this a try. Well done for giving that a try. Now I'm going to show you whether you did it correctly or not. I hope correctly. Okay, so our tractor pulls a crate up a 30-degree slope with a force of 300 newtons. The crate has a mass of 30 kilograms and the coefficient of kinetic friction is 0.3. Okay, so this is 30, right? We know that the incline there is 30 degrees, and we've got to find the magnitude of the acceleration of the crate up the hill. Okay, now again, we want to understand the free body diagram. So you've got this applied force going up, you've got friction going down, right? You'll have the normal perpendicular to the slope, and FG is always going to go straight down. But then again, FG, we want to break up into components that are parallel and perpendicular. So you'll have FG perp like this, and going down the slope, you'll have FG parallel, right? And then in terms of Newton's second law, we know that the acceleration is going up the slope. So the forces and components of forces in that line of action is going to be Fnet, right? So I'm going to start here with Fnet equals MA, right? And that's going to be the applied force FA going up. So I'm going to take up as positive, down here as negative. So it's going to be the applied force going up minus the friction going down minus FG parallel, and that's going to be equal to the MA, right? So that's in the parallel line of action, right, going up the slope. And then we also know that the normal force has to be equal to FG perpendicular in this case here, because the forces and components of forces perpendicular to the acceleration have to be balanced. Okay, so then our FA here we know is 300. Right? The friction we are again stuck on. They gave us the coefficient again. So we've got to go find FG perp again. So here, let me just draw this again nicely. So there's FG perp, here's FG parallel, here's our 90 degrees, here's our 30 degrees. Okay, so the perpendicular is next to the 30-degree angle. We've got to use cos, right? And it's a 30 kilogram block. So 30 times 9.8 gives us a weight of 294. This is going to be 294. So then FG perp is going to be 294 times the cos of 30. Right, so then 294 times cos of 30, and that is going to be 254,61. Okay, so that's now the normal force, 254,61 newtons. Okay, well done if you got that. So then we can use that in order to get FF. Now we know friction is equal to mu Kn, so I'm just going to say 0.3 times the 254,61, and then FG parallel we've now got to use sine because it's opposite the 30-degree angle, so that's then minus the 294, which is the FG, times the sine of 30, right? And that is now going to be equal to the mass times acceleration, so the mass we know is 30, and that's A. Okay, so let's clean up on the left-hand side here. 300 minus 0.3 times 254.61 minus 294 times sine of 30 gives us an answer of 76,62. Okay, so we get 70. Oh, That's supposed to be with that actually. So 76,62 is going to be equal to MA, which is now 30A. So if we take that divided by 30, we get 2,55. So our acceleration is going to be 2,55 meters per squared second up the slope. Okay, so well done if you got that.